Is our planet Earth the norm in a galaxy run through with life-bearing planets? Or is Earth a rare gem with a unique makeup and history that allowed it to give rise to living things? On Mars, Curiosity has spotted pebbles and other rocks commonly associated with flowing water. It found them downstream on what appears to be an ancient river fan, where water flowed down into Gale Crater. This shows that at some point in the past, Mars had an atmosphere, cloudy skies, and liquid water flowing. So what could have turned it into the desolate world we know today? One process that very likely played a role goes by the unscientific name sputtering. Like the other planets in our solar system, Mars is lashed by high-energy photons from the Sun. When one of these photons enters the atmosphere of a planet, it can crash into a molecule, knocking loose an electron and turning it into an ion. The solar wind brings something else: a giant magnetic field. When part of the field grazes the planet, it can attract ions and launch them out into space. Another part might fling ions right into the atmosphere at up to 1,000 kilometers per second. The ions crash into other molecules, sending them in all directions like balls in a game of pool. Over billions of years, this process could have literally stripped Mars of its atmosphere. Especially in the early life of the solar system, when the solar wind was more intense than it is today. Sputtering has actually been spotted directly on another dead planet, Venus. The Venus Express mission found that solar winds are steadily stripping off lighter molecules of hydrogen and oxygen. They escape the planet on the night side, then ride solar breezes on out into space. This process has left Venus with an atmosphere dominated by carbon dioxide gas, a heat-trapping compound that has helped send surface temperatures up to around 400 degrees Celsius. The loss of Venus's atmosphere likely took place over millions of years, especially during solar outbursts known as coronal mass ejections. If these massive blast waves stripped Venus and Mars of an atmosphere capable of supporting life, how did Earth avoid the same grim fate? We can see the answer as the solar storm approaches Earth. Our planet has what Mars and Venus lack: a powerful magnetic field generated deep within its core. This protective shield deflects many of the high-energy particles launched by the Sun. In fact, that's just our first line of defense. Much of the solar energy that gets through is reflected back into space by clouds, ice, and snow. The energy that Earth absorbs is just enough to power a remarkable planetary engine, the climate. It's set in motion by the unevenness of solar heating, due in part to the cycles of day and night and the seasons. That causes warm tropical winds to blow toward the poles and cold polar air toward the equator. Wind currents drive surface ocean currents. This computer simulation shows the Gulf Stream winding its way along the coast of North America. This great ocean river carries enough heat energy to power the industrial world 100 times over. It breaks down in massive whirlpools that spread warm tropical waters over northern seas. Below the surface, they mix with cold, deep currents that swirl around undersea ledges and mountains. Earth's climate engine has countless moving parts, tides and terrain, crosswinds and currents, all working to equalize temperatures around the globe. Over time, Earth developed a carbon cycle and an effective means of regulating greenhouse gases. In our galaxy, are stillborn worlds like Mars the norm? Or in Earth, has nature crafted a prototype for its greatest experiment? Life.